Okay. So next Thursday, this week, the Thursday, you will have the midterm. The midterm will be from chapter 10 to 12. Okay. I will write here. Okay. So for midterm, you have chapter 10, chapter 11, and chapter 12. Probably this is only maybe 15%. This around 30 or maybe 35. So half will be chapter 12. Okay. Okay. So today we will have some exercise, especially for chapter 12 and chapter 11, because in the midterm for chapter 11, I will give you a Taylor and Maclaurin, and also the Taylor's and Maclaurin's application, especially for approximation. This I will give you. Okay. And chapter 12, you will have in detail about factors, line, plane, and then the quadric surface. So I will give you some exercise for chapter 12. Let me write exercise. Find parametric equation for the line through and then okay. So this is the first exercise. Number 1, find parametric equation for the line A, line through some point and some point. B, line through some point and parallel to the equations. C, line through some points and then perpendicular to plane. So this is example for direct questions in chapter 12. You just need to find the parametric equations, meaning you need to find x, y, z with the parameter t. Easy, right? Easy, right? Easy, right? Basically, this is not really complicated. It's just like straight away answer. Okay, you can write all the questions first and then try to answer. I'll give you maybe 1 to 2 minutes. Okay, let me start with the A, line through these 2 points. So if you have 2 points, let's say point A, 4, minus 1, 2, and B. You can use for the initial point, any point, either A or B, it will be the same. Although the result will be a little bit different, but if you write down the initial point, it will be better. Okay, so first write the initial point. For example, initial point is this point, and then I need to write the direction, okay? The direction factors, or I will just simply write the v, and then I will write the v as a factor from a to b. So you can minus 1 to 4, 1 to minus 1, 5 to 2. So it will be 1 minus 4 is minus 3, 2, 5 minus 2 is 3. And then your parametric equations from the initial point, you need to adding the direction factors multiplied by t. So 4 minus 3t, and y minus 1 plus 2t, z 2 plus 3t. I will give you this is from 1 minus 4, 1 minus 1, 5 minus 2. Okay, questions? This is for A, number A. Yeah, perpendicular to plane 2x minus y plus 5z equal 12, number C. Okay. That's number A. And then number B, I will write initial point and then the parallel. I will give you notes. Okay, parallel means same directions. So if I have okay, remember this form. Okay, this is A, this is B, this is C. So I have the directions from these symmetric equations. I will write the direction factors is A, B, C, 3, 2, 1. So parametric equation will be our initial point plus the direction factor, 1 plus 3t, y is 0, just 0, and then 2t, and then z minus 1 plus t. And then c, let me write the initial point. It's negative 2 to 4. And then it said that it's perpendicular to 2x minus y plus 5z. So in this type of questions, okay, do not bother to draw. Okay, just see the direction factors, just see the initial point, and then you can just calculate everything. Okay? So if you're given the equations, don't try to draw that equations unless you are told to draw. But don't draw. Okay? You're wasting your time. But at least you have a good visualization or illustration to understand the questions. Like for example, you have initial point and you need to have a line through that initial point and perpendicular to this plane. What perpendicular means is if you have plane like this, you always have this normal factor, right? And you can say the normal factor is always perpendicular to the plane. Let's just say it's parallel, right? So our direction factors is parallel to the normal factor. Just use that the same directions. So just use the normal factor as our v, the direction factor. So our v will be 2, okay? And then just use that direction factors to define the parametric equation. So minus 2 plus 2t, 2 minus t. Okay, finish. Right. Yeah, for number 1, that's it. ABC. Okay. Good. Okay, let's try number 2. We will go for plane equation. Find equation of plane. Number A, a plane through 2, 1, 0 and parallel to plane x plus 4y minus 3z equal 1. Number B, a plane through number C, plane through yeah, you can try. And number A, I think it's easy. Number B and C, it's you need to use some process there. So the idea is you need to find in which directions that the factors you want to go, or in this case, the plane. You need to use or utilize the normal factors, right? And yeah, you need to tweak some normal factors. And you need to use the cross product to get the normal factor. Because if you use this cross product, so factor 1, factor 2, you cross that both, you get the normal one, right? Perpendicular to that. But for number 1, you can, or number A, you can directly calculate. Cross product, I think you need cross product for number B and number C. Number A, you can just directly go through. So number A, initial point is my 2, 1, 0, and parallel. Okay, parallel. So parallel, in this case, if you have the plane, so you have the same normal factors, right? And then our plane is x plus 4y minus 3z. A little bit delay. Yeah, a little bit delay. Same number of factors. And then you need to find the equation of plane. So I hope you remember how to find. I will write the equations. So A x minus, in this case, the initial point is 2. Or I just write x not first, and then B plus C. In this case, the A from normal factor is 1. So I'm just writing 1. X minus 2 plus 4. Y minus 1 plus minus 3. C, just minus 3z, get 0. And then try to solve. That's for number A. Okay, I will move to B. So you have 3 points. Okay, you have 3 points. You have 3, 4, 0, and 2, and 6, 3, 1. So any idea how you deal with these 3 points here? Yeah, find the vectors. Okay, so in this type, imagine you have 3 points here, right? This is just illustrations. So you need to set one point from all of these 3 as your initial. Set that as your initial, and then you need to find each factors. So if this is A, B, C, if this is A, B, C, then you need to find the factor AB and factor AC. And then find cross product between AB, AC, and you get the normal factors. And you will get the equation of planes from that normal factors. So let me write the first factor. I will write factor A, the little a. This is from AB, or I will write A little a here and B here. So this will be B minus A. So 4 minus 3, 1, 0 minus 1 should be 1, and 2 minus 1 is 1, also 1, 1, 1. And then factor B, it's C minus A. So this is AB, this is AC. So 3, 6 minus 3 is 3. 3 minus 1 is 4. 1 minus 1 is 0. So you have these 2 factors. And remember, if you cross this A and B, you will get the normal factors, right? So let's just cross them. So I'm using this. Wait. So it will be 0 minus 4 minus 4x for the I, and then 0 minus 3 minus, so 3, and then 4 minus 3 1. So this is the normal factor. So equation of plane, we can use the previous formula. So minus 4x minus, because I already make A as our initial point. So then I will use A as our initial point in the equation of plane. So 3 plus 3 plus 1, C minus 1. And this is the equation of plane. And please always remember how to do the cross product. Okay. If you have the A, B, C, D, remember it's always AD minus BC, the determinant in matrix. And you can also write in matrix form if you want. If you are more familiar with matrix, then we can use the matrix. So actually, you can use other point, for example, B as your initial point or C, but you need to find the other the factors and then try to find the normal factors. Maybe a little bit different, but it will be the same. I think it will be the same. It will be the same, because it is on the same plane. Okay, questions? BC You mean for your initial point? So for example, if your initial point is A, you need to find A, B, A, C. If your initial point is B, you need to find B, A, B, C. Okay? B, A, and B, C. B. The initial point is B. Yeah. Mm. Number C, you have plane. Uh, it's through the point 1, 2, negative 2, contains this parametric equation x, y, z. X equal 2t, y equal 3 minus t, z equal 1 plus 3t. So that's number C. So we go for number C now. Okay. So number C, I will write this initial point is 1, 2, negative 2. And you have the parametric, these parametric equations. So how do you do now? At least, because you have the parametric equations and the plane contains that line, you can write the v, the direction factors for the parametric equations. So the v is a, b, b, c, right? So you get 2, negative 1, and 3. At least you get this v, direction factors. And then you need another factor. Okay, you need another factor, and that factor includes the initial point. So you need to find another point and use that to minus the initial point, and that will be your factors. And how to do that? The easiest way is to set t equals some number. For example, t equals 0. When t equals 0, okay, my x, y, z, it's become 2, 0, 3, and 1, right? I have this point when t is equal 0. So I can set a factor. Let's say if I make the factor phi is my a, I will make my factor b is the difference between these 2 points, x, y, z, and the initial point. So 0 minus 1, 3 minus 2, 1 minus 2. So, oh wait. So negative 1, 1, and 3. So I have A, I have B. To get the equation of the plane, I need to get a normal factors. And we need to cross these 2 factors. So normal factor is from A cross B. Right? So let me write 2, negative 1, 3, negative 1, 1, 3. And this is the positive, negative, positive. So normal factor will be negative 3, negative 3, negative 6. 6, negative 3, 9, multiplied by minus negative 9. 2 plus 1 minus 1, 1. So I get my normal factor. And then my equation of plane, so notes, okay. So cross product for two non-parallel vector, so if you have two vectors not parallel, you cross between those two vectors, you will get the normal vector. I believe for the parallel intersections and then skew for the lines, I think you should be able to solve, right? Finding parallel intersections. And do you remember the formula for distance? Finding distance between two lines. Okay, finish. I want to move to a quadric surface a little bit. Okay, see if you still remember how to identify the quadric surface. Okay, let me move to the next slide. Identify and sketch. Not really, like I don't need really good sketches, just sketch roughly, just to show how the shape looks like. The equation will be 4x squared let's try three equations. So let's make this a. So identify means you need to determine the shape, okay? Whether it is hyperboloid, ellipsoid, cylinders, hyperboloid. There's two hyperboloid, one sheet, two sheet, right? Uh, mm, elliptical cone, right? Um, Paraboloid and hyperboloid, parabolic hyperboloid. Yeah. So if you have like really long equations for quadratic surface, you need to simplify that equations. Okay. You need to make a standard form through that equations. So for example, we have 4x squared. We have this y squared and y, right? So let's make that as our standard form. So let's make a complete standard form. So let's write 4x squared plus 4. Let me write y squared minus 2y and then let's complete our form here. It's plus 1, right? So plus 1 here, plus 1 here. Okay. So I will have 4x squared plus 4 y minus 1 squared. So I will have, if I divide all by 4, this equation. Remember, because x, y, z, you have minus 1 in y. So the center should be shifted. It's not 0, 0, 0. It should be 0, 1, 0. The center. Oh yeah, plus 4, sorry. Okay, and then you need to draw. I think by the type of these equations, you can figure that this equation is ellipsoid, right? Because it's square, 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 plus, plus, plus. There is no negative, all squared ellipsoid. and then you can check the center. Draw roughly. Hmm? No, Z. You can see from the bottom. Yeah, yeah. Yeah. So at least this one here, it will be the center. Yeah, it's like from 4, Z over 4, C squared. Yes, 2. It's 1 over 1, right? So it is the this is 1, this is 0, this is the xy. Hmm? Yeah, you can use like zeroing all the axes. Like for example, x0, and then you have the y and z. You draw the ellipse.
Point.
You need to write this is ellipsoid.
The x is also 1.
Yeah.
So
So xy
this is 1.
circle.
This is 1, right?
Xy is circle.
This is 1.
Mm.
And then here,
1 circle.
here.
Circle. Yeah. Yes. Y equal 1. Yeah. Yes. Hmm? Yes. The last part of chapter 12. Okay. Yeah. Okay. Any questions? Let's try number B. Number B should be easy, right? It's not quadric surface. So number B is for x. So it's just plane, right? So how you can find the shape? Make it 0. So do you want to draw this or just skip? Okay. Okay, so we have three equations when we are equaling x0, y0, and z0, right? So that's just normal equations, line equations, and draw the line. Yeah. So uh, first, let's see yz plane. Yz plane, when z is 0, y is -4. So 1, 2, 3, 4, -4. When y is 0, z is 2. One line, okay? And then xz plane, z equaling 0, x is 1, this is 4. X is 1. And then when x is 0, z is 2. The same here. So let's connect this. And then xy plane, when y is 0, x is 1. And when x is 0, y is -4. So just connect all these three dots. Yeah, finish. A simple plane, right? X0, Y0, Z0. Line equations. And then you make the 0 again. You need to get used, okay? You need to get used, find the XY plane, XZ plane, YZ plane. Imagine in 3 dimensions, okay? Just a plane. Number C is correct, right? Number C, yeah. Number C, y squared plus z squared equal 1 plus x squared. So let me write this. Yeah, hyperboloid. Yes. Yeah, so it should be hyperboloid one sheet. Um, yeah, if you want to trace all the vertical and horizontal trace, you can use the x0, y0, and z0. Yes. So this is the ellipse on the yz plane, and then x squared z squared. This is hyperbola. These two. So hyperbola is in xz and yz. So let's draw. So zx plane hyperbola. So maybe there. And then xy. Actually, it's not ellipse. It's more like a circle, right? It's circle. Yeah, no need. If it is in the center 0, 0, 0, just draw. Or at least if you want to make easy point, maybe the radius for the circle, the max is 1, right? So it's hyperboloid of, yeah, this hard. Yeah, good to know. Okay, good to know. Do you want quadratic surface? One more questions or jump to Taylor and Maclaurin? One more, okay. One more, I'll give you. Okay, one more question for quadratic surface. I will write the questions. Ellipsoid is created by rotating 4x squared plus y squared equals 16 about x-axis. Find the equation of the ellipsoid. So you have the ellipsoid. It was created by this ellipse 4x squared plus y squared equals 16. You rotate that ellipse and you will get the ellipsoid. And the question is asked, what is the equation of that ellipsoid? So the ellipsoid created by this ellipse 4x squared and this ellipse rotated about the x-axis. So x-axis is the center of the rotations. Four x squared. No. Yeah, ellipse. With x, with a is 2, b is 4. So remember, in ellipsoid, you have x squared, y squared, and z squared, right? So you need to plus z squared, c squared. So you need to find z, right? Z, the third axis, the third axis. Okay, any idea? Hmm? If z is 0, we will get the original ellipse, right? As the question is. So let's just draw the ellipse, okay, the original ellipse. So x over 4, so it should be 2, and y is 4. Any idea? So imagine this ellipse, okay? Imagine the ellipse, the original ellipse, like I draw, okay? Imagine that ellipse rotated through this x. So try to rotate the ellipse. What will you get? What will you get? No, no, no. The trace, the trace, the trace. Yes, correct, correct. So if you have this is 4, when you go here with the full rotations, imagine like a rotation for a circle. So it will be a circle. So this is 4. So this is a circle. So you get easily the Z or C is 16. Just using drawing, you will get, right? Right? And this is your ellipsoid. The question is asking rotating through x-axis. Then the same thing, if you rotate to y-axis, so it will be the same as the x. So it will be 4, right? Yeah, yeah. The ellipse will rotate on that plane. So you can write when rotated through or about. No, sit down first. Sit down first. When rotated about x-axis, okay, there. What's your question? Yeah.
If it rotates along this x-axis, so how does this x-axis line is like this, right?
What do you mean?
So
Here. Listen. This is my x and y. This x, I put rotator.
okay.
So it
Okay.
follows this, right? So it like
Mm.
this point.
So if
moving around.
this is 4 and this is the x, it will be okay. And sometimes, okay, if you feel confused how to imagine the drawing, you can use the projections, okay? 2D projections. So this is the 2D projection. So YZ plane, 2D projection. So in many cases in quadric surface, sometimes you need to project into two-dimensional, like in YZ plane or maybe XY plane, XZ plane, depends on the questions. So it makes your visualization in quadric surface better. Okay, I will move to the now Taylor and Maclaurin. Okay, Taylor series. Remember? Okay. So Taylor series, if you have the functions, you need to define the functions in centered in some constant. So this is the Taylor series form. So for example, if you are asking find find Taylor series. The functions is maybe ln x, and then centered at a equal 1. So Taylor series means you need to expand the polynomial equation defined by the functions, okay, expand that, and then try to make the sum of that all expansions. So for example, you have the functions is ln x. So first you write fx ln x, right? The first derivative is 1 over x. I will write x to the negative 1. The second derivative, right? Third derivative, at least 4, or maybe 3, 4, maybe 5, depends on you. And then we plug in the a. It's 0. So it will be 1, right? It will be negative 1. It's 2. Okay. At least you get all this constant. Okay. And then plug in all this number and this derivatives inside the Taylor series. So ln x, you can rewrite the functions of x as the fa is 0 plus 1 x. Because a is 1, I will write x minus 1. Okay. And then the second derivative is negative, x minus a 2 factorial. And then third will be 2 and then maybe 4. 4 is negative 6. Okay, I just need this 4. You can try to 5, 6, it depends on you. But for now, I'm only just need this 4. Let's simplify the factorial. Okay, 2 factorial means 2 multiplied by 1, right? 3, 3, 2, right? And 1. 4, 3, 2, 1. So I can cancel these 2, and it will be left 3, right? And then this 4 factorial, I will cancel this 6 with this 3 and 2. Okay, so I will write this as I will remove all the factorials. And the next step, we need to define all of this into our sum. Okay, remember the infinite series, sum for the infinite series? Let's do that. So ln x, let's start from 0 to infinity. Let's start from the bottom. It's only 1, 2, 3, 4, right? We can just say it's n plus 1. And then x minus 1 is also n plus 1. But because it is alternating series, we need to multiply by negative 1. Because it's positive, negative, positive, negative, positive, negative. Alternating signs, right? So we need to multiply by negative 1 n. You can rewrite the form a little bit different. That's okay, as long as it is still correct. That's also fine. Like for example, n minus 1 or n plus 1 depends on which positive at the first terms. Sometimes it's negative, sometimes it's positive, depends on the equations. Yes, this is how to say, elaboration from the power series. Remember centered in radius convergence? Yeah, similar. So you can also find the convergence, like radius convergence, from this sum also. So sometimes the question is also asking what is the radius of convergence from this. So you can also find. And then if you are centering the Taylor series A equals 0, that will change into Maclaurin series. That's just the difference is just that. Okay. So the answer will be this, and yeah, this whole answer. Actually, sometimes it depends on the questions. Sometimes the question is only asking the expansion form. Sometimes it's asking the representation in infinite sum series. And sometimes it's like for example, finding the radius of convergence. How to find the radius is from the sum, the infinite sum. And you can use the ratio test and then find the radius. If you forget in detail for the Taylor and Maclaurin, go see the video, the YouTube video. I believe there are several functions that I think you better remember one or two. I think like sine, cos, or maybe just sine. Because cos, you can just derive the sine and it will be your cosine. And maybe ln e to the x. Maclaurin series is centered at 0. That's called Maclaurin. The Taylor series is just the default. All the expansion is called Taylor series. Depends on the question. It can be 2, 3, always 0. Okay. If I'm asking find Maclaurin series for cos x squared. Okay, so to help you get the idea for Taylor and Maclaurin, you can try develop your own Taylor and Maclaurin series by your own, especially these functions, sine x, cos x, what else? At least these 5 maybe. Okay, for example, because sine and cosine is related, cosine is derivative of sine, so you can find the sine and get the sum series, and you just need to derive that sum, and you get the cosine. So if you know the cosine, at least the cosine x, if you know the formula, to find the cos x squared, you need just to change the x with x squared. For example, I will write the conclusion for cos x. So if I have cos x squared, let's change the x into x squared, and then with the order of 2n factorial, and then you'll get the final is let's just say x to the 4. This you can get from sine. I will show you how to do the sine. So ff is sine. So I will write for you. So you will get both sine and cos. Actually, I already show this method in the video, but I will show you anyway. So it will be 4 will be back to the original, and if you have 5, it's similar to this one, 6, 7, and 8, and repeat all over, right? Maclaurin, A is 0, so F0 is 0, F then you need to just expand 0 because because A is 0, it's on the X. 0 again, let's write 0 minus X and then 0, and it should be plus okay. I will have my sine X is X minus, it will be positive, negative, right? So it should be 7 right? So I can write this as sine X equal because it's odd number, so I will set an odd number to n to n plus 1 factorial. So this is for sine, okay? And then if you want to derive and make it cos, you need to minus 1 the n, right? And you will get this. I just need to show you that you can use integration and derivatives to find the sum. So from sine, you want to derive and make it cos, then you just need to derive the sum. Maclaurin is always 0. 0, yeah. You know the Maclaurin, if the question is asking Maclaurin, so you can just use that the A is 0. So what the Taylor and Maclaurin do actually, so you have a functions, you can expand that functions. So you can use the Taylor polynomial as a polynomial series, and you can actually approximate the same value for the, for example, you want to know sine of something, or maybe a really difficult equation or functions, and you want to approach it through this expansion, and you can do it. This is you can use this for approximations. You can use the remainder theorems. Theorem. Watch my video about Taylor and Maclaurin. Yeah, I will use it for the midterm. So another thing is, let me show you the if my functions so if you have the function ln 4 minus x and you need to find Maclaurin series, you can have at least two ways. One way is you can imagine this 4 minus x. If I write this, it will have minus, right? You can use this approach, 1 over 4 minus x. It is the same thing as, remember that if you have 1 over 1 minus x, it will be the same as, right? This is the infinite series for 1 plus x squared plus x cubed, right? So we need to use this form and make it 1 minus the variable. So let's factorize 4. So we can have, right? So we can have 1 over 4 okay, and then you can finish the rest. Yeah, maybe at the very end you can make it merge together again. Yeah. Okay, you can do it, right? Okay, last example. I will show you how. No. Find 4th degree Taylor polynomials. So another example questions. You need to use the Taylor polynomials with all that information to approximate some numbers. For example, 1.1. So you will use the same method as the Taylor exponential, Taylor polynomial. You find the expansion and then use it to approximate the number. For example, if you have the 4th degree, 4th degree means you need just to stop at the 4th derivatives. Stop there, and that's your equation. So I will write for P4 x as your polynomial. So 0. It's the same formula as before. And stop here, and I will get cancel, remove the factorial. Okay, and then after that we try to change the x into the number that we want to approximate. Yeah. So 1.1 minus 1, 0.1, change the x. Okay. Oh, wait. 1, sorry. X minus 1, minus 1. So you get this. Use your calculator. Evaluate this number. Yeah, it should be, in my calculation, is around 0.09. Try in your calculator the easy one. ln 1.1. I will show you why it's important. The questions. Fifth until five derivatives. But actually, this is really directly the information is directly told, right? But sometimes it's not really direct. For example, find the blah blah blah, and then the error or the accuracy needs to be in some error point, and you need to find backward from that error. Yeah. But probably I will just give you like this, similar. Yeah. So the more degree you add to your Taylor or Maclaurin series, the more degree that you add, the more accurate your calculation will be. So it's quite similar. So the difference is in here from 0.00001. The accuracy is here within this 0.0001. So the more degree you add, the more derivatives you add, the more accurate your calculation will be. If the question is not really asked or the information is not complete, then you can assume with any A. For example, you just need to approximate some number, and maybe you can from that number you can get maybe use A equal something, right? That really close to that number. So that's all for the exercise. I hope you focus on the especially the chapter 12 and then chapter 11, especially the Taylor and Maclaurin. I will ask you the Taylor and Maclaurin, also the factors. Okay, the quadric surface, at least one quadric surface or two, and line and plane equations. And the rest maybe one question about chapter 10. Maybe the convergence, the divergence, like last one, like the last quiz. But it's not really focused on that.